Hello, this is Nigel Bowden, and today I'm going to be taking a look at 10 easy things you can do with your WLAN Pi. WLAN Pi sometimes has a reputation as being something of a geek's Linux box that only Linux gurus are able to access and use, but there are plenty of features available that don't involve accessing the CLI at all and be available and accessible to many people. So I just want to run through some of those today. The kit I've actually used in this video is the standard Neo 2 SBC running an image version 1.9.1, which is the latest one at the time of recording. I'll just burn that onto a little SD card and put that in there. It's just a fresh out of the box image with no modification or configuration, so this is something you could certainly do yourself. And with that, for wireless connectivity, I've got the Comfast CF912 AC wireless adapter, and these are the main component parts which are supplied if you buy any of the pre-built WLAN Pi kits, and they're the recommended items if you decide to build your own kit up. I've actually got WLAN Pi on the desk next to me. I've got a camera trained on it, so we can have a look at that to see what's going on with that later on. So I'll be doing all of the testing on that. I've just got the wireless adapter plugged into the one of the USB ports of the WLAN Pi. I've also got an Ethernet cable plugged into it, and also a USB serial USB to serial adapter cable, which we'll have a look at using a little bit later. But I've got all this set up on the desk next to me, because I can't really move it around too much because it'll ruin the camera shots for you. So I've got that set up. I've also got a desktop switch which I'm using for internet connectivity and to allow us to browse into the WLAN Pi. So I'm going to be looking at 10 different features and looking at maybe some scenarios where you might use those in the real world, and we'll walk through those and I'll give you a demo of each one to show you how easy it is to use. Okay, so the first feature we're going to be looking at is, let's imagine we've got a scenario whereby we've got an access point which maybe connects to the cloud, needs to get out to the internet to be able to talk to its management and controller, and we're having a few problems with it. So the first thing we want to do is have a look to see exactly what the state of our switch port might be, and the WLAN Pi can be quite useful for this. And so what we're going to do is initially plug the WLAN Pi into the port that's been vacated, because we've unplugged our access point, so we can see if we can get some idea what the connectivity issue may be. So I'm just going to switch on my WLAN Pi camera so you can see it. And there we go. Yeah, you can see that now. Just pop my cursor up there. Okay, so if I just press the button, it's gone into a power save mode, so you can't actually see too much. There we go. So now you can see we've got the WLAN Pi. This is the front panel. We've got the 3 buttons there, which we use for maneuvering around the front panel management system, and we are showing a default address of 192.168.42.1, which is the address you see, which is assigned to the USB adapter by default whenever you power up the WLAN Pi. So we haven't actually connected any external network connections to it yet, which is why we're seeing this. So the first thing that we're going to do, we want to understand what state is our Ethernet switch port in. So I'm just going to plug in the Ethernet cable into the switch port. So hopefully after a few seconds we should get some indications as to what's going on. So we have got we can see we've got a 1 gig port and it's running full duplex. We're still showing a locally assigned or self-assigned IP address. That could be my DHCP service, a little bit flaky. Let me just reseat that, see if we can force a DHCP request. Let's give that a few seconds, and hopefully we'll see a network assigned IP address. Here we go, fingers crossed. There we go. This time we've been lucky. We've got the IP address. So we're now seeing an IP address of 192.168.0.29 on our Ethernet port. So straight away we can see our Ethernet port is live. It's a gig port running at full duplex. Our DHCP assignment is actually working. So we're in pretty reasonable shape. So you know, we haven't got a sort of basic physical level type problem or internal layer 3 connectivity issue on this port. So we need to move on and do a little bit more investigation. So the next thing we're going to move on to is what we need to do is maybe somebody's recabled the switch, or recabled our drop cable. Maybe we're not going into the correct switch. We really need to understand, are we still connected where we expect to be? So we need to maybe try and ID the switch that we're actually on. So we'll do a quick demo of how we do that. Oops, sorry, I've jumped ahead slightly. Here we go. So now what we're going to do on the WLAN Pi, I'm going to actually navigate around the menu system, and what we want to do, we actually want to have a look at the LLDP or CDP information from the switch, so we can see, is this actually on the switch that we expect it to be on? So I'm just going to navigate there, and we want to go down to the LLDP neighbor information, hit next, and there we can see LLDP neighbor information. So this is the information we're getting from the switch that the WLAN Pi is connected into. We can see it's called switch.home.local, which is my rather unimaginative name for my home switch. We can see we're actually on port gig 03, and if I hit the down button we can get a little bit more information. We can see the switch is assigned 192.168.0.253. We can see the VLAN 1 that we're operating on, and we can see it's a Cisco switch, and we can even see it's a 3560. So we get some fantastic information. We know, whether we're on the right switch, we're on the right switch port, and whether everything associated with that switch port is as we expect it. If we don't have LLDP running on the switch, we can have a look at CDP, and we get pretty much the same information again as you would expect. So fantastic feature. So now we know we're actually plugged into the switch that we expect to be plugged into just by plugging the WLAN Pi into the switch port. Okay, so we're pretty happy with the fact we're in the right switch port. Maybe there's something else going on at a network level that we need to have a look at. So the next thing we want to have a look at, has the switch port got access to the internet? It's very important if we're using a cloud-based access point, so we need to be able to test that. So again, we can use the one of the features within the WLAN Pi to take a look at that. So I shall switch on the camera. There we go. So this time what we're going to try and do is we are going to have a look at the reachability information provided by the WLAN Pi. I'm not sure if I've pressed that button correctly. There we go. So yeah, we can see straight away, this is the information that is being derived from that switch port. We can see that we're able to ping Google, we can do a HTTP GET to Google, ping our gateway. We can see we've got DNS name resolution is working correctly. So we can see that we are getting out to the internet, and things are looking pretty good from a DNS point of view and basic pinging out to the internet. So we're in pretty good shape here. I don't see too many problems with this. So I think as a final test, maybe it would be nice to actually be able to sort of run some data out to the internet. So we'll go on to our next test, which is again same setup again. We've got the WLAN Pi still plugged into the same Ethernet switch port, and we just want to run a quick speed test. So let me just get us onto the speed test feature of the WLAN Pi. So we go down to speed test, hit next, start the test. There we go. I didn't press it quite firm enough. They do need a little bit of brute force sometimes. So now the WLAN Pi is running that speed test, and as when you run a speed test, to UCLA, which is what this is doing, it takes about 20 or 30 seconds to actually run through the entire speed test process. So it'll be doing an upload and a download, and you can see on screen now we've actually reported it. So we're actually showing downstream speed of just under 40 meg, upstream just over 10 meg, which is, given my setup here, is the sort of best that I would expect in this scenario. So yeah, we're in pretty good shape. So you can see, using the WLAN Pi, we've not sort of had to go onto the CLI, do anything fancy. Just purely by plugging into Ethernet switch port, we've been able to get some pretty detailed troubleshooting done just by manipulating the buttons on the front panel. I think the next thing that we're going to move on to, I'll just switch off that camera again. Next thing we're going to be looking at is if we've got a situation whereby we've got perhaps a wireless client which is complaining that they're not getting very good performance. First thing a lot of people do is tend to do some sort of speed test out to the internet, but you know, using a test server which is out on the internet has fairly, or can have fairly mixed results, because you're going over so many domains, network domains that you don't control, and any sort of poor results you get could be outside of your control. It could be your internet link, it could be the actual speed test server. So very often it's really nice to have your own iPerf server. So you can just stick it on the internal network and run some internal tests, and you know, if you've got good performance internally, then you're looking at something a little bit beyond beyond your internal network, and maybe something out towards the internet, or more at the extremity of the network. So out of the box, the WLAN Pi has actually got iPerf.2 and iPerf.3 enabled. You literally just have to plug it into a switch port. As long as that switch port has got DHCP enabled, you're good to go. So what I'm going to do now is, as I say, we've now got this WLAN Pi plugged into an Ethernet port. We should be able to run a test, an iPerf test to it. So let me just get us ready to roll here. Okay, so you just go back to the top. I just need to know what the IP address is. So the IP address that this has got is 192.168.0.29. That's going to be important for our test. So let me just get my command prompt up so we can run our iPerf test. So here we go. So we're going to do iPerf. This is going to be an iPerf.2 test initially. iPerf-C for client, and we're going to be running to 192.168.0.29. Oops, .29. And we're going to go for show samples at an interval of 1 second, and we want to run for 10 seconds. Let's see how we go. There we go. We can see we've actually connected, and we're running by default. iPerf runs TCP test, and we can see we're running a TCP test. We've varied between around about 123 and just under 200 megabits per second. So we can see we're running pretty well internally. So we've not got too many issues there, and we also can do the same thing with iPerf.3. Both of these services are running out of the box. You don't have to do anything to set them up. When you power it up with the default image, they're just available, and they're listening and will respond. So there we go. You can see on port 5201 this time we've got iPerf.3 listening, and we can see we can run a test there, and yeah, things looking pretty good. So yeah, a really nice, quick and easy test device for you to run some performance tests. It is absolutely invaluable when you want to test inside of your network. Okay, so the next item that I want to run over, or want to have a look at, is out of the box. The WLAN Pi also allows you to provide a remote wireless scanning probe facility, and this is used with Wi-Fi Explorer on the Mac, or WinFi on Windows 10. And if we have a look here at the scenario that we're looking at here, I've actually got at the bottom left hand side, we've got our laptop, which is, in this case, it's going to be running WinFi because I'm doing this on Windows. I'd like to show you what Wi-Fi Explorer as well, but I haven't got my Mac set up. But maybe do a separate video on that, because Wi-Fi Explorer, works really just as well as WinFi for this, and provides fantastic insights as to what's going on in remote parts of your network. So we've got the laptop, we've got a couple of switches here. It's just representative of a network. So maybe you've got a large corporate network, you can't get to a remote site, and you get somebody to hop along there and just pop a WLAN Pi onto a switch port somewhere, and that would enable you to then collect data for Wi-Fi Explorer or WinFi to just do a wireless scanning to see exactly what's going on there, what's going on over the air. So I'm going to do a little bit of a demo of this with WinFi. Again, this is out of the box. I've not set anything up. It will just do this. You don't have to touch anything on the setup of the WLAN Pi at all. So let me fire up WinFi, if I've got it here somewhere. Okay, now the way that we actually do this is, by default, you can see we're actually scanning at the moment, and this is using the internal adapter of my laptop. So what I'm actually going to do, I've got network connectivity to the WLAN Pi on the desk next to me, but this could be a remote part of the network, it could be over a VPN connection, however you can get the connection across to it. So what I need to do is, I think I need to stop the scanning first of all. There we go, stop the scanning. And what I need to do is manage WinFi interfaces, and then you can see we've actually got the option to set up a WLAN Pi as a remote sensor. So what I'm going to do now is configure that, and by default, normally in this IP address field it would show 192.168.42.1, which is the default address if you're using the local USB connectivity. But as I've already been testing this, you can see I've already got the IP address of the WLAN Pi in there. That's the only thing I've had to change. The port setting and the default username and password, which are the defaults out of the box for the WLAN Pi, they're already set up, so I haven't had to do anything there. What you can do when you've actually put in your IP address, you can actually hit the test button, and that will test that you've got network connectivity so that it can start gathering the data. You can see we're successfully connected, we're good to go, which is good news. And if I hit the scan, whoops, I've hit the wrong dialog button there we go. If I hit scan, it takes a few seconds. What it's actually doing at this point is doing an SSH session out to the WLAN Pi, actually pulling back some data for each channel. It scans through all the channels, and then it will present it on the screen. And there you can see now we're actually showing all of the data. You can see we're using the WLAN Pi to gather that, and it will just keep scanning periodically and keep pulling that data back over an SSH session. So I know in this case, obviously the WLAN Pi is next to me and it's not very impressive, but if this was on a remote network somewhere, you would obviously have a window into what's going on in that environment. And as you know, if you use wireless scanners a lot or frequently, you know just how valuable this is in understanding what's going on in a particular area. So that's a fantastic feature of the WLAN Pi. And as I say, Wi-Fi Explorer, exactly the same, out of the box, boom, you can just point it at the WLAN Pi. As long as you've got the IP address, and if you're using the default credentials, away you go. Really powerful feature there of the WLAN Pi. So we'll just stop that now so it doesn't cause us any problems later. Okay, so that's using the WLAN Pi as a remote scanner probe. Next thing we want to do, this is a really useful and powerful feature of the WLAN Pi. Again, we don't have to get onto the CLI to do anything for this. This is actually profiling a wireless client. And now when we're designing a wireless network, it is key that we understand the capabilities of our clients. For instance, if they don't support particular 5 gig channels, it's no good firing up APs on those 5 gig channels. So we need to understand exactly how each of our clients works. And the way that we do this is to actually take a look at the association frames from the particular client that we're interested in. And by analysing the data that's in there, we can get really good indications of the various 802.11 amendments that they support, channel support, things like that. So this is an incredibly powerful feature. So to get this one going, sorry, just run through this scenario. We've got the WLAN Pi, which is going to be running the Profiler process. I'll show you how to start that up from the front panel. It's just connected into an Ethernet switch, and I've just got my laptop connected up so that I can browse into that, so we can see the report, the client report at the end. For the device to be profiled, I've just got a little iPhone here, an old iPhone. So I'll fire that up and we'll have a look to see how that profiles. So let me get my camera sorted out. Here we go. So first thing I want to do is fire up the profiler. So I go to menu, and I want to go down to apps and go down to profiler, and I want to start it. If I do status, you see it's not running, so I'll go back and go down to start. There we go, it says it's now running. If I exit out of that and go back to the status, it is just starting up. There we go, it's finished starting. So we can see now it's running. It's actually running on channel 36 by default, and it's using an SSID of WLAN Pi by default. Those are configurable if you want to change any of those, but we're not going to dive into that now. I just want to show you the default easy to use features. So what I'm going to do now is, if I have a look on my phone, I should have let me just see if I've got the SSID there. Just give it a second. Aha, right, sorry, it's just popped up. I don't know if you can see it on there. We can just see at the bottom there it says WLAN Pi. So I'm just going to hit that, and what that does, it prompts me to enter a password. I can enter any old rubbish, because all we're interested in doing is getting the phone to try and send an association frame so we can analyze it. And if you look on the front of the WLAN Pi now, we can see it's seen one client, and based on the Mac OUI, it gives you an indication of the manufacturer. So it says Apple, so we can be fairly certain that it's been this that has tried to associate. And what's happened now, the WLAN Pi has captured the association frame, done some analysis, and we should be able to see what it thinks it can and can't do. So let me just fire up my browser and we can browse into that. Sorry, I just need to close my camera. And where's my browser gone? I think I may have... Oh no, there it is. There it is. Okay, so we will browse into it. So we just go to 192.168.0.29, so I'm just browsing straight into the WLAN Pi. And if we go look at the profiler section here, and we go into the clients directory, we can actually see this entry here, which is a folder which has got the information in that we want. And we've got two files that are created for each of the clients. We've got a PCAP, which is the actual association frame, so if we want to, we can get that, analyze it for ourselves if we just want to double check things. And we've also got a little text file here, so if I click on that, that actually shows us what the profiler thinks this particular client can do on 5 gigs. So we can see we've got 2 spatial streams. We can see that it supports pretty much all of the 5 gig channels. We can see we got 11K, 11I, 11V. So we get a really good indication as to what this client can do, and that can be invaluable for making decisions on wireless designs. Okay, so that's the profiler. Again, didn't have to touch anything on the CLI. It was just literally enable it, and away we go. In fact, I think I will just disable it before we carry on to make sure we don't get any interference with any subsequent tests. So I shall go into Profiler and do a stop, and there we go, that's killed the process. Okay, so we're ready for our next feature. So the next one we're going to have a look at is Remote Wireshark capture. This is similar to the remote wireless scanning, but obviously this time we're using we're actually using Wireshark to pull layer 2 frames which are being detected by the WLAN Pi. So we've got on the left hand side here, we've got the laptop which is running Wireshark. We go across some type of network. We've actually got the WLAN Pi, which is just plugged into a switch port somewhere. It's got an IP address from DHCP, and we can actually fire up Wireshark and instruct the WLAN Pi which channel we want to be running on, channel width, things like that, so that we can actually pull back wireless frames and do some analysis. The only slight caveat to this, I've not done anything on the WLAN Pi, but on Wireshark there is a little bit of setup to do. You have to enable SSH dump during a Wireshark install, and there's a script to install. There's one for Windows, a different one for Mac. It's a very painless operation. It's a one-time operation. I'm not going to cover that now. I just want to keep things simple, but I'll fire up Wireshark now so you can see exactly what happens. So let's just see if I've got my Wireshark ready to go. I think I may have closed it inadvertently. Here we go. Let me just get it going again for you. Hang on. Okay, and of course it's on the wrong screen. There we go. So here we go. So this is a standard Wireshark screen, and if I scroll down to the bottom of the interfaces which are presented, you see we've got this additional WLAN Pi remote capture interface. So if I double click on that, there we go, we actually get the option to set up the various parameters that we want to pass to the WLAN Pi to do the wireless capture. In this case I've set it up for channel 100 because I know there's something going on there. We've actually, we can pick any of the any channel we want. I've also set it to capture on 40 megahertz, so it'll be channels 100, 104. In terms of the server, we put the address of the WLAN Pi in there. I've already tested this before, so it says the correct address 192.168.0.29, and the authentication is just WLAN Pi, which is the default username and password for the WLAN Pi. That applies to all of the tests where we need to supply credentials. This, when you're using this utility, that is the default, so it should just work without any additional steps required. So I've hit the start button, and hopefully now, there we go, we can see we're actually pulling some 802.11 frames. These are being pulled directly over the network from the wireless NIC card of the WLAN Pi. So you see that's an incredibly powerful feature to be able to have. If you could pop one of these on a distant part of your network and pull back some information, some wireless frames, and do some analysis to see exactly what's going on. So you can see again that was a relatively painless operation. I was able to just plug in the WLAN Pi to an Ethernet port, point Wireshark at it, and away you go. So very straightforward, very, very powerful feature which is available with the WLAN Pi. The next feature we want to look at is, it's one of my favourites actually. I really like this one. It's a fairly simple one, but it's amazingly useful when you're out in the field. This one allows us to use the WLAN Pi as a serial wireless a wireless serial console. So if maybe we want to be doing some work on the console port of a switch and it's in a cold data center and we want to be sat somewhere nice and warm, we can plug this into the serial console port of the switch and then sit hopefully somewhere a little bit warmer and just get a wireless connection into it. So it's a terminal server type thing. So what I need to do for this one is, let me just switch my camera back on. So sorry, just run through the setup. We've got our laptop here. It's just got a wireless connection through to the WLAN Pi. The WLAN Pi broadcasts an SSID which we can join, and then on the other side of the WLAN Pi we've got a USB to serial cable, and the actual serial port or serial plug of the cable plugs into the serial socket on the Ethernet switch. So let me just bring up the WLAN Pi again. Here we go. So what I need to do this time, because we have to actually make quite a few changes to the networking components of the WLAN Pi, we actually flip it into a completely different mode. Because we have to set up, different wireless connections, and there's all sorts of bits we need to change, and it's not something that you can simply just change one or two config files and go. So what we're going to do is select the Wi-Fi console, hit confirm, and what actually happens at this point is that it will actually do a reboot. So we've copied a load of files into new locations, do a reboot to make sure we get a nice clean restart of the networking part of the WLAN Pi, and then when it comes back up we should be broadcasting an SSID that we can join onto, and when we join that SSID we should be able to just get onto the serial port of the switch that the our USB to serial cable is connected to. So we can see that the WLAN Pi has rebooted into Wi-Fi console mode. You can see it's using an internal address there of 192.168.42.1. It's showing that that's assigned to WLAN 0. So what we should be able to do now is have a look to see if we can see the Wi-Fi console SSID, and then we should be able to join that and get access to the serial console. So if I just have a quick look in WinFi, I'll just switch this off so you can see what's going on. You can see at the top there we've got the Wi-Fi console network name, so it's available for us to join onto. We just need to actually join that SSID. If I just click on this, we should be able to join the Wi-Fi console SSID. It may have remembered my credentials actually from the last time I tested this. Normally you would be prompted and you would just put in a password of Wi-Fi Pros, which is the default out of the box. So you can just join one time and remember it for future use. You can actually go into the WLAN Pi and change that if you're not happy with having the default pre-shared key, but that's you can dive into the documentation, find how to do that. Okay, so we're actually connected now. I will minimize WinFi. So we've actually got a wireless network connection. What I'm going to do now is fire up a terminal session, and what we actually have to do now, we've got a network connection to the WLAN Pi. We just need to fire up a telnet session on port 9600 to the IP address of the WLAN Pi, and that should get us onto the serial console port that we're after. So if I just do a quick connect, I shall do a telnet session to 192. Oh, it was correct address already, sorry, from previous testing. 192.168.42.1, which was the IP address we saw on the front panel of the WLAN Pi. We have to use telnet. That may sound insecure, but don't forget we're going over a pre-shared, we've got a pre-shared key encrypted connection that we're running over, so it's not too much of a concern. And we're using port 9600, which is that gives us a 9600 bits per second connection on the serial port that we drop onto on the back of the WLAN Pi. There are other ports available actually. You can use port 4800 if you've got a 4800 bits per second, port 2400 for a 2400 bits per second, etc. So there's a number of options there, but the most common one is 9600 bits per second. So if I hit connect now, there we go, we can see we've actually made a connection. If I just hit return, we can see we're actually on the serial port of my switch here on the desk. So the way we're getting to that is I've got a wireless connection to the WLAN Pi. The WLAN Pi has actually got a USB to serial cable plugged into the back of it, and that goes into my Cisco switch on the desk here. So theoretically I could be in another part of the house or another part of the building and still able to access the serial port of my switch, which is a very useful feature, a very useful convenience feature if you don't want to be sitting in a cold equipment room. So that's the serial console feature. The final feature that I actually want to look at is using the WLAN Pi in hotspot mode. What this actually does, it boots the WLAN Pi into another mode. We actually come out of the wireless console mode, and we need to flip into hotspot. In fact, I shall do that so it can do that in the background while we're just talking, because it does take a few seconds. So we're in Wi-Fi console mode. I just need to go back to classic mode. The classic mode is just the default mode out of the box, and we go confirm. So that will actually switch back into classic mode now. So while it's doing that, I'll just carry on explaining what we're doing. Yeah, so what we're going to do, we're going to drop the WLAN Pi into hotspot mode, which then causes the WLAN Pi to act as a small scale AP. So we will actually be broadcasting beacons, and then we could actually use that potentially for doing things like attenuation measurements for walls when you're on site doing a survey, if you want to figure out the attenuation of walls of different parts of the building, and maybe feed those into into some sort of predictive modeling. Right, I'm just going to boot the WLAN Pi into hotspot mode. There we go, hotspot, confirm, and that'll reboot now. Again, as with the wireless console mode, we've got quite a few network changes to make, and so we need to change some files, do a full reboot to make sure we get a nice clean network stack coming back up. So in this particular scenario, it's fairly simple. We're just looking at attenuation measurements. But what you can actually do, which we're not going to cover in this particular exercise, you can actually plug an Ethernet cable into the Ethernet port of the WLAN Pi, and we have actually got forwarding enabled, so that you could, if you wanted to, join the SSID, which is broadcast by the WLAN Pi, and then actually get routed out on the Ethernet port to, say, if it's connected to a switch which has internet connectivity, would enable you to get out onto the internet. So there's quite a few use cases for this, and I'm just looking at sort of the easiest one that we've got, just to give you a quick demonstration of it. So if I just now, hopefully I should be able to fire up my little cam again. Here we go, and we can see we're now in hotspot mode. We've got an internal address of 192.168.88.1. That is the address that you would connect to if you were actually going to form a connection and wanted to pass through the WLAN Pi to route out to the far side. But we're not actually going to be doing that today. But just very quickly, if I fire up my WinFi and just give it a chance to refresh. I think actually this is on 2.4 gig, 5 gigs this time. Yeah, you can see on 5 gigs we've got the WLAN Pi hotspot SSID, which is available, and we could potentially use that for doing wall measurements, etc. And as I say, we can use it as a small scale access point to extend network connectivity if we so choose to. So I think that's pretty much everything I've got to show you. Let me just take this screenshot off. There we go. If you need to know any more about WLAN Pi, I thoroughly recommend you visit WLANPi.com. You can always find myself and Jerry on Twitter, and we'll always be glad to help you out with any challenges you've got, any suggestions you've maybe got for the WLAN Pi. We are developing the platform on an ongoing basis, and gradually improving things over time with input from the community. So hopefully this has been a useful exercise in understanding 10 really useful, really powerful, easy to use features that you can use on the WLAN Pi just by firing up a fresh image, not having to do any configuration, no CLI work whatsoever. Nice and straightforward and very powerful networking utilities. Okay, thanks very much for your time, and hope to see you again soon. Take care. Bye.